Welcome to the DIY Honda Garage channel. DTC P1747 indicates a problem in the shift control system of the Honda Civic models from 2006 to 2011, specifically related to the cut valves. This code indicates that cut valve A may be stuck in the on position, or cut valve B may be stuck in the off position. These valves play crucial roles in controlling transmission fluid flow to facilitate gear shifts. When these valves malfunction, it can lead to transmission performance issues, affecting the vehicle's drivability. Understanding the functionality and positioning of these valves is key to addressing the DTC. Mechanically, the cut valves are located within the transmission system, specifically in the servo body and main valve body. Appropriate troubleshooting is essential to resolve this error effectively and to restore normal transmission operation. DTC P1747 relates directly to malfunctioning cut valves within the shift control system of the Honda Civic. Cut valve A and cut valve B are critical components located in the transmission servo body and main valve body, respectively. Their primary duties involve regulating the flow of transmission fluid necessary for proper gear shifting. When these valves operate correctly, they allow smooth transitions between gears, maintaining vehicle performance. However, if cut valve A becomes stuck in the on position, or cut valve B remains stuck in the off position, it disrupts the balance necessary for effective gear control. Understanding the placement and functionality of these valves is essential for diagnosing the problem and ensuring successful repairs. Several potential causes can lead to the activation of DTC P1747. Firstly, cut valves A or B may become stuck, preventing them from properly regulating fluid flow. Such malfunctions often stem from wear, contamination, or debris buildup in the transmission system. Another plausible cause is related to transmission fluid levels. Leaks can result in low fluid, compromising the system's ability to operate correctly. Additionally, excessive clutch material or metal debris in the strainer could indicate more significant internal transmission issues, necessitating further investigation or even complete transmission replacement. Each of these factors should be meticulously checked as they all contribute to potential shift control system failures. Drivers experiencing DTC P1747 may notice various symptoms indicative of shift control issues. One common symptom is transmission slippage, where the vehicle hesitates or loses power while trying to shift gears. Additionally, a delay in shifting can be experienced, leading to an uncomfortable driving experience and potential safety concerns. Increased noise during gear changes may also occur, often caused by improper fluid flow due to malfunctioning cut valves. Recognizing these symptoms early allows for timely diagnostics and repairs, reducing the risk of further damage to the transmission. Overall, immediate attention to these symptoms is crucial for maintaining optimal vehicle performance and safety. The first step in troubleshooting DTC P1747 involves warming up the engine to its normal operating temperature, which ensures that all components are functioning as they should be. You will know the engine is sufficiently warmed when the radiator fan engages, signaling that the engine has reached its optimal temperature. This process is critical as it allows for accurate diagnostics and ensures the transmission's fluid is operating at the correct temperature for testing. Maintaining the proper temperature can also prevent erroneous readings that could lead to misdiagnosis. Hence, ensuring that the engine is warmed up correctly sets a solid foundation for the subsequent troubleshooting steps. The second troubleshooting step requires checking the transmission fluid level and inspecting for any potential leaks. Proper transmission fluid levels are crucial for effective operation. Low fluid can lead to transmission issues and can be a direct contributor to DTC P1747 being triggered. Inspecting for leaks can prevent further complications by identifying if the system is losing fluid, which can compromise its functionality. Ensure the fluid is not only at the right level, but is also in good condition. Contaminated or burnt fluid should be replaced, as it indicates potential damage within the transmission system. Careful examination of the fluid and the entire transmission can lead to crucial insights during the troubleshooting process. In the third step, you will drain the automatic transmission fluid ATF through a strainer to inspect for any metal debris or excessive clutch material. This is a vital process as it can provide significant information regarding the internal condition of the transmission. Metal debris or high quantities of clutch material can indicate wear and tear within the transmission assembly, often signaling the need for a repair or overhaul. If excessive debris is found, it drastically changes the needed repair approach, often necessitating a complete transmission replacement. Conversely, if the strainer is clear, this points towards other components potentially at fault, allowing you to continue diagnosing the issue more effectively. For the fourth troubleshooting step, turn the ignition switch to the on second position to prepare for clearing the DTC using the Honda Diagnostic System, HDS. This step is critical as it allows the technician to reset the error codes, providing a fresh start for monitoring system performance. When the ignition is on, it engages the electrical components necessary for the HDS to communicate with the vehicle's onboard systems. This process can sometimes help determine whether the DTC is a persistent issue or an intermittent failure. It sets up the system for the subsequent testing and diagnostics that follow, making it an essential step for thorough troubleshooting. Moving to the fifth step, upon turning the ignition on, use the HDS to clear any stored DTCs from the vehicle's memory. This action resets the system and eliminates previously recorded errors, allowing for a more accurate assessment of the vehicle's current performance. Clearing the DTC is crucial before performing any test drives, since it ensures that you are working with up-to-date diagnostic information. After clearing the codes, a vehicle will need to be test-driven to ascertain whether the problem persists. If the same or a new code appears after the test drive, it indicates a potential ongoing issue that still needs troubleshooting. In this sixth step, the next task is to test drive the vehicle while keeping the shift lever in the drive position. D. During the test drive, the vehicle should shift through all 5 gears to ensure that the transmission is functioning properly under normal driving conditions. This real-world assessment is vital in determining if the problem related to DTC P1747 still lingers after clearing the codes. Observe how the vehicle responds during the drive. Any hesitation, slipping, or failure to shift may indicate further issues requiring deeper investigation. This test checks both the mechanical and electronic aspects of the shift control system, offering insights into whether the repairs so far have been effective. Step 7 involves monitoring the onboard diagnostics (OBD) status for DTC P1747 via the HDS diagnostic tool. The OBD system continuously evaluates the performance of various vehicle components, and by checking the DTC's menu, you can ascertain the status of the Diagnostic Trouble Code you previously cleared. If the HDS indicates failed, it points towards persistent issues within the system, prompting further repairs on cut valves A or B, or potentially the need to replace either the main valve body or servo body. Additionally, should the HDS show passed, this may signify a temporary or intermittent issue that does not presently affect the system's performance. Full understanding and analysis of the OBD status is essential for thorough troubleshooting. The 8th step in the troubleshooting process requires you to again test drive the vehicle while in drive, allowing you to verify whether the shift system is functioning without issues. During this test, it is important to ensure the vehicle shifts through all 5 gears smoothly, just like before. This step serves as a follow-up to see if the repairs made were successful and if the problem indicated by DTC P1747 has been resolved. If any signs of issues recur, it could lead to further diagnosis or repairs. Continually test driving helps confirm the effectiveness of the service or honoring the work that has been done thus far. In the 9th step, you will check for any pending or confirmed DTCs using the HDS diagnostic tool. At this stage, you want to see if DTC P1747 has reappeared. If it is indicated, it means the issue still needs to be addressed, and you should revert back to Step 4 for further troubleshooting. If no DTCs are confirmed, it suggests that other systems have been restored to functionality, and you can proceed to the next verification step. Understanding pending codes allows you to identify intermittent or upcoming issues and take necessary action before they escalate into larger problems. For the final troubleshooting step, monitor the OBD status once again using the HDS. At this point, you are looking for confirmation that the system is operating correctly. If the HDS reads passed, this indicates that your troubleshooting efforts have successfully resolved the underlying issues related to DTC P1747. However, if the HDS shows failed, it means that the problem persists, leading you back to the troubleshooting beginning at Step 4. Should the status read not completed, you would need to revisit Step 8 and continue with the monitoring process to ensure thorough diagnostics. This final monitoring step is crucial for confirming the integrity and reliability of the repairs made. The final repair verification stage is imperative for confirming the effectiveness of the repairs made to resolve DTC P1747. At this point, you ensure no new diagnostic trouble codes have appeared after the troubleshooting and repair process. Testing the vehicle under real driving conditions ensures that all functions are operating smoothly and confirms that the cut valves are now functioning correctly. This verification gives the technician confidence that not only has the original issue been addressed, but also that the overall transmission system is reliable moving forward. Documenting this step further assures the integrity of service on behalf of both the customer and the technician alike. To prevent future occurrences of DTC P1747, regular maintenance is essential. This includes performing routine checks of the transmission fluid level and its condition. Ensuring fluid is clean and at appropriate levels is critical for the longevity of the transmission. Additionally, inspect the transmission components like cut valves during regular service intervals to ensure they are functioning properly. Keeping an eye on the overall health of the transmission can help catch minor issues before they escalate into major failures. Encouraging preventive maintenance promotes better vehicle reliability and performance, reducing the risk of unexpected breakdowns or costly repairs. In conclusion, DTC P1747 highlights critical issues with the shift control system in Honda Civic models from 2006 to 2011. By thoroughly understanding the components involved, such as the cut valves, and following structured troubleshooting procedures, effective diagnostics and repairs can be achieved. Identifying symptoms early on aids in timely interventions, and rigorous ongoing monitoring can prevent future issues. Additionally, performing preventive maintenance can significantly enhance vehicle performance while extending the life of the transmission system. Ultimately, proper recognition of DTC P1747 not only ensures vehicle reliability, but also reaffirms the importance of comprehensive diagnostics in automotive service. Please like and subscribe to the channel. See you next time!